The AUVSI Foundation is a non-profit educational foundation that's focused on creating hands-on robotic programs for students K through 12 as well as college, mainly with the purpose of getting them interested and focused on robotics as a career path. One of the important things with the competitions that we do right now, especially at the collegiate level, is that all of these events require full autonomy, which means all of the computing power and the sensors and the systems that they have to build together and work together reside within the vehicle itself. And that's a critical distinction, and it's a very complex distinction that makes this different from remote control.
Hello, my name is Jay Biereski, and I'm on the Cornell University Autonomous Underwater Vehicle team. I work on computer vision software for the team. Our AUV uses a Portwell Mini ITX embedded motherboard, which has a quad-core Intel processor for all of our vision processing needs. We've also evaluated Core i7 and the new codenamed Sandy Bridge processors, and we have seen a great performance increase in our algorithms.
My name is Jean-François. I'm from École de Technologie Supérieure in Montreal, Canada, and I'm part of Team Sonia. As part of our computer vision system, we use OpenCV, and one of the interesting things about OpenCV is that underneath, it actually uses the Intel Performance Primitives library. And as Intel optimizes it, OpenCV automatically uses those improvements. This translates into dramatic performance improvements for us without any further engineering effort on our part. Using an Intel processor actually uses those performance primitives and allows us to get really blazingly fast performance for a computer vision system. And as we know, having a fast computer vision system allows us to get more advanced analysis, better feature detection, better feature extraction, and also allows us to get a vehicle that responds faster and more accurately to some of the challenges it might meet underwater.
What we've seen because of the complexity of the competition and the requirements that are put on the teams and their vehicles is that they all need the maximum ability to process information that they can get. Because of the performance aspects, they all migrate toward the Intel products. And that is something that it takes one team to talk to the others about how well their Intel systems work, and they all end up going in the same direction. So it's a pattern that we've seen the teams work toward and move toward the best products that they can find, and certainly Intel is a big part of that.
People in the robotics community have this feeling that right now, robotics are where the personal computer was in, say, the late 70s. It's just starting to hit that big exponential increase where they're starting to be deployed everywhere. We're encouraging the students to use integrated packages or integrated architectures like JAWS, the Joint Architecture for Unmanned Systems, so that they'll be able to collaborate more often and share the kinds of techniques and strategies for solving the problems they have to solve in an unmanned autonomous system.
Most people are familiar with robotics in general, but I think the important distinction about autonomous robotic systems, those that are not being controlled by a person in real time, is that they're able to do a lot of things that are either dull, dirty, and dangerous. Those are sort of the three catchwords that explain why we use autonomous systems. The dull, dirty, and dangerous are things like going into the deepest parts of the ocean and doing exploration. And the autonomy part of it really allows us to do things that would not be done otherwise by a human being.
Currently, we're pushing out more and more autonomous systems, not just for the military, but also for the commercial industry. Lockheed Martin, MS2 in Riviera Beach, Florida, we're doing systems for the oil and gas field and other energy systems.
Things that were impossible for us 2-3 years ago are now plausible, and these teams here are on the cutting edge of what's plausible, and a lot of these technologies I've seen here will start showing up later in real-world robots.
Probably the singular most critical piece of technology that has allowed robotics to advance to where they are today is the computer itself. The processing capability that the Intel products provide are critical to what we're doing here. So computing power is absolutely essential and key, and the advancements in the computer industry are what have really driven the robotics industry.